All right, today we are taking on how to simplify a radical. So here in problem 1, what I'm seeing is the square root of 4. So what I want to do is I want to look for pairs, because for every pair that I have underneath my radical, I can pull them both out and write 1 on the outside to represent the pair that was underneath. So if I look at 4, 4 is a perfect square. That is 2 times 2. So I have a pair of 2's. So remember what I just said. For every pair of the same underneath the radical, I pull them both out and I write 1 on the outside to represent the pair that was underneath. So I'm going to go ahead and circle this group of 2 of the same and write that my answer here is 2. So the square root of 4 is made up of 2 times 2. I have a pair of 2's, so my answer becomes just 2. Okay, I'm going to do the whole left-hand side, and then I'm going to pause, and I want you to work through the right-hand side, and then you can check it with my work in the end. Okay, so the next one, 3. Square root of 12. Okay, so 12 is made up of 4 times 3. Okay, 4 is a perfect square. Right? It's made up of 2 times 2. So I have a pair of 2's, but I have a 3 that's going to be left behind underneath the radical. So on the outside, I have a 2, and underneath, I have a 3. And if I want to double check, did I do that right? I could always take the 2 right here, square it, so I'm back to 4, multiply it by the 3 that's underneath, and would that get me back to the 12 that I have originally? And it does. So the square root of 12, right, simplifies to be 2 times the square root of 3, or 2 root 3. Okay, let me slide up and go on to problem 5. So problem 5, I have the square root of 150. So I'm going to do my little branch here. Think of 2 numbers that multiply to 150. So if I'm looking for a big perfect square, I can see, oh, 25 goes into 150. So 150 is 25 times 6. So 25, I have a pair of 5's. So here's my pair of 5's. And with that 6, 6 is made up of a 2 and a 3. So I have these little dead ends right here and here. There's no pair that I can scoop up to pull them out. The only time that I can pull out from underneath a square root is if I have a pair of the same value. So here I have that pair of 5, so I have a 5 on the outside, and then underneath my radical, that 2 times 3 will multiply back to get me to 6. So knowing that, I could have actually just stopped right here and known, oh, there's not going to be a pair of 6, and leave the 6 right there underneath the radical. So my final answer is 5 times the square root of 6, or 5 root 6. Okay, next one is problem 7. I have the square root of 72. Let me just slide that up. So square root of 72. So if I'm looking for a big perfect square that goes into 72, I can see, oh, well, that's 36 times 2. And 36 will give me a pair of 6's with that 2 that stays behind. So on the outside, I have a 6, and underneath, I have a 2. So again, for every pair underneath the radical, I pull them both outside, and I write 1 on the outside for every pair that was underneath. So I have 6 times the square root of 2, or 6 root 2. Okay, another way you could have approached it, let me just point something out. I could have just gone fully prime factorization. So if I look at the square root of 72, maybe I don't notice that 36 is a perfect square. And I see, okay, well, that's 2 times 36. And at 2, I'm at a prime number, so a dead end. 36 is 2 times 18. So here again, 2, prime number, dead end. 18 is 2 times 9, circle the 2. And the 9 is 3 and 3. Okay, so what I've done this time instead is I've really just broken it down to its prime factorization. And then I can look for individual pairs. So I can see, oh, well, I have a pair of 2's right here, and I have a pair of 3's right here. So on the outside, I would have a 2 times 3, and underneath, that little lone 2 right here doesn't have a partner to pull it out. So that stays behind underneath the radical, just like that. And then it multiplies back to be 6 root 2. So I'm just trying to show you another process for how you can break it down. The goal really is to just find the most efficient path for you. So I would hope that at some point you're able to do it quicker, just like I did over here. But if it is something that is easier for you to see by breaking it down prime factorization, you're welcome to do this method as well. They both lead us to the same end result, that's 6 root 2. All right, next here, this last one, 9, I have 3 times the square root of 80. So here I need to make sure I see that there's a 3 already on the outside. I usually just underline that so I draw attention to it. And then I simplify the square root of 80. So 80 is 16 times 5. And that 16 gives me a pair of 4's. Okay, so since I had a 3 already on the outside, I have 3 times. Here, the pair of 4's underneath, so a 4 on the outside, with that 5 staying behind. So when I multiply this back, I have 3 times 4, that gets me 12. 12 times the square root of 5, or 12 root 5. Okay, so I want you to pause the video for a moment, and I want you to do the evens. I want you to do that right-hand column, and then when you're ready, you can unpause it and look at my answer key, or you can watch me rework them one more time. So hit pause for a moment, unpause when you're ready, and then I'm working through this right-hand side. Okay, so square root of 9, perfect square already. I can see that it's a pair of 3's. So square root of 9 is just 3, nice and easy, just like that. Okay, square root of 18, I can see that that's 9 times 2. That 9 gets me a pair of 3's. That 2 is going to stay behind. So on the outside, I have a 3. Underneath, I have the 2. So 3 times the square root of 2, or 3 root 2. Slide it up. Okay, square root of 60. So 60 is 4 times 15. That 4 gets me a pair of 2's, just like that. The 15 is not going to break down. There's no pair of the same thing. I know it's a 3 and a 5. So I could stop here and say 2 times the square root of 15. Or I could keep going if maybe I didn't notice that. Where I have this 3 and this 5, those are my dead ends right there. So I have a 2 on the outside. Underneath, I'd have to multiply back the 3 and the 5. Right? They did not have a partner to pull it out. So I have 2 square root 15. Okay, let me slide it up. Last 2. So for 8, I have the square root of 200. Well, 200 is 100 times 2. And that 100 will give me a pair of 10's with that little sweet 2 staying behind. So on the outside, I have a 10. Underneath, I have the 2. So 10 times the square root of 2, or 10 root 2. That's how we usually say it. Okay, and then the last one here, I have a negative 5 times the square root of 108. I don't want to lose that negative 5. So negative 5 times the square root of 108. And now I'm going to simplify 108, the square root of 108. So 108 will be 36 times 3. So 36 times 3. And then 36 is a perfect square. It's going to give me a pair of 6's with that 3 staying behind. So I have a negative 5 already on the outside times 6. And then underneath is the 3. So I'm left with negative 30 times the square root of 3, or negative 30 root 3. All right, have a good rest of your day.